We have the BH curve apparatus and the detailed manual for it. Also, we have probes as well as a jack and 3 non-magnetizing specimens. So now we'll start the experiment. We'll connect the x-axis of the CRO to this point. This point. This is the ground terminal and the y-axis to this point. As we can see, both the grounds of x-axis and y-axis are shorted and connected to this ground terminal. Now we will short this part of the circuit. From here we can also take the reading of the ampere, that is the current, and we can also get this value from the manual. If it is at set point 1, then it will be around 1 ampere. If it is at set point 2, then it will be around 1.2 ampere, and if it's at set point 3, it will be around 1.5 ampere. For this experiment, we will do the experiment at 1 ampere. The CRO is now at XY mode, so we will we have brought this point in the middle position. Okay. So now we will put in the specimens. For this experiment, we are taking 2 specimens. As you can see, we have got a curve already. Now we will change the control knob A and control knob B to get a better curve. First, we will change the scale so that we get a proper curve. Okay. If there are loops, as you can see in both the ends, then we will change the control knob B to get a curve without any loops. Okay. Make sure that both these parts are almost parallel to the x-axis. So this is coming almost parallel to the x-axis. So this is the curve that we are getting. Now we will trace this curve in a millimeter graph paper, and we will calculate the area of the BH curve from there, as it is also shown in the manual. Here the calculation part is shown like this. You will have to calculate the area of the curve. Here, from this formula, we will get the calibration of x-axis. For the calibration of b-axis, that is the y-axis, we will have to do this procedure first. That I'm going to show you. So now we will select channel 1 and we will reduce the scale so that we get a straight line that will be the length of the BH curve. Okay. Make sure that the control knob A is in the minimum position so that no resistance is induced in the secondary part of the circuit. The control B knob will be in the same position as it was. From here we will calculate the length. Here it is 5.8 centimeter. Okay. Now we will take out the rods till the height is half of what it was, that is half of 5.8 centimeter, which is 2.9 centimeter. So we are approximately getting 2.9 here. Okay. Now select channel 2 so that we can change the scale of the y-axis and bring it back to what the length previously was, that is 5.8 centimeter. We will again do, this was one time, we will again do this, bring it to half of its length, So this is half of its length, and again we will change the scale. Okay, so this was 2 times. Now we will again do this, and we will keep doing this till the rod is completely out. So this is 3 times, and now it's changing. So 3 times was the maximum. So now we will take the specimens completely out, and we will now take the new height. We'll measure this new height. This is due to the flux of the air core inside the solenoid. So now with the readings that we have taken, we are going to do the calculation. Everything is given in a detailed format in the manual. So we will find the H max from here, the calibration constant for x-axis and b-axis, as well as from the BH curve we will find retentivity, saturation, as well as hysteresis loss per cycle per unit volume. This is an example of the calculation and how to do it. So that concludes the experiment. Thank you.